The Southeast Asia Energy Transition Partnership is a program of the United Nations Office for Project Services and is a multi-donor partnership of government and philanthropic partners working to facilitate sustainable energy transition in Southeast Asia. We empower our partner countries Indonesia, the Philippines, Vietnam, and projects across the region to transition towards a sustainable energy system, generate economic growth, and ensure energy security. At the heart of our work lies a deep commitment to creating a sustainable future, aligned with the Paris climate targets and Sustainable Development Goals. Our mission is to facilitate a just energy transition in Southeast Asia.
Hello everyone, by way of introduction, I'm Stuart Thorncraft, consultant at Intelligent Energy Systems. I worked in the role of team leader for the UNOPS Energy Transition Partnership sponsored project, which was entitled Development of Smart Grid Roadmap for a period of up to year 2030 with a vision to 2050. This project was implemented jointly by Intelligent Energy Systems with our partner EWEC in Hanoi, Vietnam. We implemented this project over the period from early 2023 through to about March 2024 with Vietnam Electricity Regulatory Authority as the primary counterpart organisation. The goal of this presentation is to provide a quick overview of the project's findings. To that end, I will briefly recap the project's objectives, its outputs, give some detail on the approach we used, and then conclude with the main findings. For detailed information on the project results, please refer to the accompanying project reports and documents. The project's main objective was to develop an updated smart grid roadmap for Vietnam, with a particular focus on the period to the year 2030 and a vision to the year 2050. It was implemented under the UNOPS Southeast Asia Energy Transition Partnership in cooperation with the Electricity Regulatory Authority of Vietnam, or ERAV. This comes in response to the need for a new smart grid roadmap in Vietnam that will address current as well as anticipated challenges facing Vietnam's power grid to support the energy sector transition and accommodate higher levels of renewable energy, as well as phasing out fossil fuels. It's envisaged that the role that smart grid technologies will play will be very important to this. The main outputs from the project were to do an assessment on the status of smart grid in Vietnam, review and report on smart grid technologies as well as international experience, develop a draft updated smart grid roadmap for consultation, and then finalise the updated smart grid roadmap with feedback from the consultation. It's important to define what we mean when we're talking about the term smart grid, because the term is often used to mean a wide variety of different things. On this project, as is the case in Vietnam, we consider smart grids to be technologies that enhance the efficiency and flexibility of a power system, where the technologies can span the entire conversion chain. This means generation, transmission, distribution, and end users or customer applications. An important enabler for smart grids is communication technologies and communication infrastructure. This is because smart grids rely on the exchange, processing and taking actions on high volumes of data, including control schemes, price signals, smart inverters and other technologies that can be deployed as part of a smart grid. So our overall approach to updating the smart grid roadmap in Vietnam was firstly to take a look at the existing policy for smart grid in Vietnam. Secondly, to look at the extent to which that policy had been implemented. Thirdly, to then do a general review of all smart grid technologies that could be deployed in Vietnam. And then finally, review and take a look at international standards and regulations that have been established elsewhere and identify those that would be needed to be developed and established in Vietnam. All of these were used as inputs that went into the updated smart grid roadmap to the year 2030 with vision to 2050. In terms of existing smart grid policy in Vietnam, we undertook a review of the two main policy documents that guide smart grid development in Vietnam. The first of those was Prime Minister Decision number 1670, which was promulgated in 2012, And this basically set out the first smart grid development roadmap. As you can see, it went out to the year 2023 and was implemented across 3 different phases. Second item of legislation that was implemented was MOIT decision number 4602, which came into effect in November 2016, and it was concerned with approving a comprehensive smart grid development plan. One of the things that distinguishes that legislation from the earlier roadmap is that it set out very specific targets across different areas of smart grid. As you can see to the right, SCADA EMS and SCADA DMS technologies, power grid remote control and switching centres, modernising metering, and ensuring investment efficiency and cost savings through appropriate investment in scientific and technological research efforts. From our assessment of smart grid status and implementation in Vietnam, we made a number of observations. The most important ones were that further modernisation in monitoring and control in real-time power system information would be able to enhance visibility and flexibility, and that is necessary in order to support higher levels of renewable energy. It is necessary to continue to progress the remote monitoring, implementation of advanced metering infrastructure, and eventually start the rollout of smart metering infrastructure. Advanced infrastructure and monitoring capabilities to better accommodate distributed energy resources, including behind the meter solar rooftop and behind the meter energy storage, as well as accommodate intelligent end use appliances and electric vehicle charging infrastructure will be necessary. And the final area that was high priority was the continuation of promoting demand side management, demand response, energy efficiency in order to maximise participation and engagement of end users, thereby capturing the opportunities for flexibility on the demand side. The Smart Grid Technology Review, we identified all of the key technologies that have been deployed in smart grids internationally across generation, transmission, distribution, and end-use applications. We then worked through the question of whether the technology has been deployed in Vietnam, whether a target for its development existed, and whether there was a technical standard already in place for the technology. This enabled us to identify gaps in terms of technical standards for technologies that may be deployed in Vietnam in the future. Having done this based on Vietnam's power development plan and other policies, we determined whether the technology needed to be deployed prior to 2030 or after 2030, say before 2050, and whether it needed explicit treatment in the updated roadmap. The details are set out in our report, but this analysis basically allowed us to identify the technologies that needed to be included in the smart grid roadmap, what sort of priority should be assigned to each technology, and how regulations and standards should be developed for the technologies. In our review of international experience, we had a number of recommendations. The first of these recommendations was to take measures to include generation technologies such as smart inverters, utility scale battery and energy storage systems, and virtual power plants. Second sort of area in terms of transmission technologies was to provision for flexible AC transmission, accommodate HVDC technologies, and increase real-time monitoring and management of variable renewable energy resources, implement dynamic line rating approaches, implement WAMs and PMUs, as well as look into special protection and control schemes to maximise the utilisation of the network. Supporting advances in distribution network technologies and operations included the rollout of advanced distribution management systems, fault location isolation and service restoration schemes, wider use of real-time GIS mapping and displays, substation automation, and distributed energy resource management systems. Finally, creating an environment that would allow for prosumers or end user engagement in the industry is important, and key technologies that enable this to happen include advanced metering infrastructure, meter data management systems, smart meters, home automation systems, intelligent appliances, intelligent building energy management systems, and the Internet of Things to increase flexibility at the demand side. Other areas observed from international experience included improving the scope, bandwidth, reliability, and nature of communication networks, including wide area, local area, and smaller scope networks in order to support the communication between end user devices or small scale devices and other systems. The other areas included enhancing data management systems and analytics through deployment of cloud-based services and data warehouses, as well as edge computing and the use of GIS mapping and analysis software packages, as well as rolling out artificial intelligence to analyze large data sets. The final area that's incredibly important that we observe from international experience is taking measures to ensure cybersecurity risks and threats are both preempted and mitigated as part of ongoing operations of all of the players within the electricity system. To organise smart grid technologies, we propose to use the framework that's shown in this slide. To the left, we have real-time measurement, monitoring, and control. This includes applications that are often built into energy management systems or advanced distribution management systems. These applications increase network transfer capability and increase efficiency of grid operations and therefore allow the absorption of more renewable energy. To the right, the framework is concerned more with end users and intelligent devices to enable so-called prosumers. This includes small-scale distributed generation, small-scale storage, and price-responsive end users. The rollout of all of these technologies creates a lot of data that needs to be analysed and monitored. Hence, the top of the pyramid, we have included data management and advanced analytics. This makes the data available to the industry and has as its objective to improve efficiency. Finally, at the bottom, we show communications infrastructure, which is core to the successful operation of all components in the system. We chose to structure the updated smart grid roadmap for Vietnam using a similar structure to the previously implemented policy on smart grid in Vietnam. So we basically have the objectives, the legal and institutional structure, which is broken down into an organisation model, regulations and standards. We then have technology and infrastructure, where we're primarily looking at what type of KPIs, key performance indicators, should be imposed for different core technologies that need to be included in the updated smart grid roadmap. So this includes real-time monitoring and control, substation automation, metering infrastructure, communications infrastructure, data management and analytics, and cybersecurity. And then the final area is the outcomes. So what are the outcomes intended for the policy? So the outcomes include programs and initiatives, research and development areas, as well as overall performance targets for the implementation of the smart grid. The updated smart grid objective is to continue the development of a smart grid in Vietnam with the deployment of modern technologies that will aim to enhance power quality and supply reliability, contribute toward the efficient management of power demand, encourage efficiency in the use of energy resources, enhance labour productivity, reduced demand in terms of investment in power grid and resource development, strengthen reasonable exploitation of energy resources, ensure national energy security, and support the energy sector transition towards a net zero greenhouse gas emission by 2050, while also contributing to environmental protection and sustainable socio-economic development. To support the implementation of the Smart Grid Roadmap, it's important to put forward an organisational model. In the updated Smart Grid Roadmap, we leverage the concept of a Smart Grid Steering Committee led by the Ministry of Industry and Trade, which will involve EVN Group and numerous ministries that would be directly involved. It is envisaged that the steering committee would monitor and oversee the implementation of the Smart Grid Roadmap. An important feature of the updated Smart Grid Roadmap was to identify legislation and regulations that would be needed to support the technologies that are included in the updated roadmap. Required regulations for implementation prior to 2030 include incentive mechanisms for the smart grid applications in new and renewable energy, zero energy buildings, and energy trade between consumers and power companies, otherwise known as prosumers. Also, incentive mechanisms for synchronous condensers and residential customer participation in DR and DSM schemes. The responsibility for the development of such regulations is put onto Ministry of Industry and Trade and ERAV, as well as involving some other ministries, including the Ministry of Finance. Other required regulations for implementation prior to 2030 include regulations for the integration of energy storage systems, smart appliances capable of adjusting demand based on supply conditions or the electricity tariff, and distributed energy resources. Some lower priority regulations include virtual power plants, electric vehicles, and vehicle-to-grid mechanisms. This is mainly because of the timing of when these technologies are expected in Vietnam. Another important area for the updated smart grid roadmap was technical standards. So technical standards generally require Ministry of Science and Technology to lead, with support from the Ministry of Industry and Trade and ERAB. Technology infrastructure targets and key performance indicators are also important, and these have been included for the following areas: real-time monitoring and control, substation automation, modernisation of metering infrastructure, implementation of programs and initiatives to promote demand response and distributed energy resources, EV charging infrastructure, enhanced data management and analytics, communications infrastructure, and cybersecurity. Much of the responsibility for technology infrastructure rollout is placed onto EVN Group. The final area of the updated smart grid roadmap were outcomes. We defined three general areas for the outcomes. The first one was promotion of programs and special initiatives. So what we want is the outcome, the programs and initiatives that create incentives to develop the smart grid technologies that will be required. The recommended approach by 2030 was to include commercial DR programs, distributed energy resource integration, and systems that will support the integration of electric vehicle charging stations in the grid. The second area was power system performance measures, where the goal is to have measures that define what we expect as the performance of the power system. These covered system reliability, electrical losses, and a threshold on curtailment levels of variable renewable energy resources. The final area was research and development. As an outcome of the smart grid technology roadmap, we want to promote initiatives for the industry to undertake research in smart grid technologies and have a focus on piloting new technologies and testing them ahead of their wide-scale deployment and scaling them in the country. Thank you very much for your attention, and I hope you've enjoyed this presentation.